Okay, this is page 5. We are into reviewing Unit 3. Okay, we are on page 5. This involves fractions, so now we're reviewing our fractions. It says, I can illustrate a diagram that accurately represents a fraction and its parts. That means I can draw a picture. Okay, I can look at the fraction and I can draw a picture that matches it. So our instructions say, illustrate a diagram that represents each fraction expression below. So here's my fraction, 4/5 plus 3/5. If you notice, the denominators are matching. When I add and subtract, the denominators need to match. So I'm going to go ahead and make a fraction bar. It needs to have 5 spaces. And we got 1, 2, 3, 4, and 5. We're going to pretend they're equal, even if they're not equal. Okay. Doesn't have to be perfect. Okay. I'm going to draw. Need 5 more. 1, 2, 3, 4, and 5. Okay. So whatever the bottom number is, I need 1 less number of lines. So notice I need 1, 2, 3, 4 lines, right? And that gives me 5 squares. Okay. The shape, the box that we make, or if we're making pie circles, okay, it needs to represent the total number. Okay, the denominator means in total. So I have a total of 5 pieces. In the first one, I have 4 shaded. So I need to fill in 4. 1. Actually, I'm going to make it a different shade. Just kidding. I'll make it purple. 1, 2, 3, 4. Okay, so I have 4 shaded, and on the bottom, I'm going to need 3. 1, 2, 3. Now this says value as an improper fraction. Okay. So to do that, an improper fraction means the top number is bigger than the bottom number, right? The numerator is larger than the denominator. So I'm going to count how many shaded pieces I have. 1, 2, 3, 4, 5, 6, 7. Okay. And 4 plus 3 is 7. Okay, so they match. 7 is going to be the numerator, the top number. And the denominator stays the same. I do not add 5 plus 5 is 10. Okay, keep it the same, 5. Now, it says value as a mixed number. Okay. There's a couple ways we can convert this to a mixed number. Since I have diagrams, I will use diagrams to show. Okay. If I took this number 7 and filled it up here, I would have 1 complete row. And then I would have 1, 2 left over. Okay. So that would give me 1 and 2/5 because we moved that one. So I have 2/5 now. Okay. 1 and 2/5. Now 5 goes into 7 one time, and then I would have 2 left over. 6, 7, right? 7 minus 5 is 2. So any way I'm looking at it, the numbers are the same. So I know it is correct. Now that I've finished that problem, going down to the next, let me block out what we don't need to look at. Okay. Roll up. Mask. Now I am looking at 7 over 6 plus 5 over 6. And again, the denominators match. So I'm drawing a box. And how many spaces am I going to have in it? 6. Even though this says 7, we go by the bottom number. Let me actually make this a little bit thinner. Here. Try this again. Make sure I have enough room for it. There we go. Make my lines. So what did I say last time? You want one less line than the number. So if that's 6, I want to make 5 lines. 1, 2, 3, 4, 5. Notice how this is very uneven here. All right, I'll just erase that. I try to have even numbers here, but it doesn't work all the time. Even spaces. Let's try this again. 3rd time's the charm. Okay, there we go. So I have 1, 2, 3, 4, 5, 6. Black out that top part again that we were not looking at. And then if I were to shade this one in, yeah, I was using purple to do that. And I counted 1, 2, 3, 4, 5, 6. Well, I have 6, but I need 7. So what is it that I need to do? I hope you're thinking that, well, Ms. Johnson, you need to make another box, because that is correct. So I made another box. I need 6 more even spaces. 1, 2, 3, 4, 5 to make 6. And I'm shading in 1 more. There we go. Now I have 7. But I need another box because all that is for this one. So now I need 5 over 6. I need to do this again. Okay. Make my lines. Right. Shade it in again. And I'm going to shade 5. 1, 2, 3, 4, 5. Okay, now I have 5 over 6. So on this side, I need to write it as an improper fraction. So if I count at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Also, 7 plus 5 is 12. So I checked it. I am correct. Cool. Is this number going on the top or the bottom? The top. And the bottom number stays the same. Okay, now on this box, I need to write it as a mixed number. If you notice, this number 7 can fit right over there. If I do that, I'll have 2 rows that are completely full and 1 row that's empty. That'd be like 0. So that's 2 holes. And all fractions are division problems. So I look and I see, you know what? 12 divided by 6 is 2. So I go to 6, 12, and it is 2, which matches this 2. So it's a whole number. There is no mixed number. So there's, you don't write 0 over 6, just 2. We're all done with that one. My eraser, go. All done with this one. Let's black that out. Scroll up now. I need to create fraction expressions that represent diagrams and or real-world problems. So read your instructions. Create a fraction expression that represents the given diagram and matches the criteria in each column. So I'm looking at these pictures and I need to make the fractions. I need to look at this and write it if it was an improper fraction, if it was a mixed number. Okay, and then the sum of two fractions and different two fractions, we did a certain way that I will show you. So just focusing on the first one right now. I can count 1, 2, 3, 4, 5, 6, 7, 8. Notice how I made a mark in each one that I counted. You do not need to write the whole number. I'm doing that for an extra visual. So the total number in all is telling me what number will be on the bottom. Okay, so this is out of 8. So I have 8 and I have 4 here. So I need to add the 4. So 8, this is 9, 10, 11, and 12. Okay. So as an improper fraction, the numerator will be 12 because there are 12 shaded pieces, okay, 12 parts. Now, how do I write that as a mixed number? Well, this is one whole one, so that gets a 1. And this is 1, 2, 3, 4 out of 8. So as a mixed number, this is 1 and 4/8. You may notice that the 4/8 can be reduced to 1/2. Okay, that's not the focus. That is not what is on acquisition right now. So we can write 4/8. That is okay. If you're comfortable reducing this, simplifying it to 1 and 1/2, then please do so. I'm going to write this as a sum. Sum means plus. Whoa. What just happened? Don't erase everything. I don't know how to make that go away. Sum means plus. Okay. Difference means subtract. Okay. So I'm going to put a plus sign here, and then 1 and 4/8. That's all we're doing. We don't need to solve it. We don't need to come up with two fractions that add. Okay, we're just going to write it as a sum and then how it would look if it was a difference. Okay, so 12 over 8 minus 1 and 4/8, or 1 and 1/2, depending on what you're using. Very nice. Let's go down to the next one. Okay. Hide what we don't need to look at. Okay, so I'm going to count and find out how many is in my denominator. Okay, remember, I only count the total number for one of the rows. So I have 1, 2, 3, 4, 5, 6, and 7. Okay, that tells me 7 will be my denominator. Okay, I'm not counting all of them or only all the shaded ones or including or not including the white ones. People do different things, okay? The denominator is the total number of parts for one complete, in this example, row, okay? Now to continue on to find the numerator. Now I'm counting all the shaded pieces only. So it's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so I have 18 over 7. As a mixed number, I see one row is complete. I see a second row is complete. Okay, this one is incomplete. So 2 is my whole number. And then how many do I have? 1, 2, 3, 4. Because I'm still counting the shaded pieces. I'm not counting the unshaded ones. So 4 is the numerator, and 7 stays the same. Okay, so if we write this as an improper fraction, I'm looking at 18 over 7. If I'm looking at it as a mixed number, well, I have 2 whole ones, right? If those are candy bars, I have 2 full candy bars. On my third one, I ate 3 pieces of. Okay, that's what we're saying. We're saying I have 4 pieces left and 2 full candy bars ready to go. So when I write this as a sum, I have 18 over 7 plus 2 and 4 sevenths. When I write this as a difference, I hope you're pausing this one, especially for the next one. I want you to put it on pause and try to do the problem and then check to see if our answers match. Okay? 18 over 7 minus 2 and 4 sevenths. There we go. Erase. Look at what we are no longer looking at. If you want to look at your paper, for examples, you can, but that way when we're looking up here, less confusing. Okay. There we go. Oh man, I have so many squares. Am I going to count each and every one? That would take a long time. So let's do a little shortcut. I'm going to count in this column how many rows are going down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And then in the row, the top row going across, I'm going to count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I take this 10 and I times it by this 10, it will tell me the number for all of them. Okay. If you want to think about it, it could be like finding the surface area of this cube. Okay. So 10 times 10, go to my chart here. 10 times 10 is 100. So that tells me what my denominator is going to be. 100. Now for my improper fraction, so I know I have 100. Maybe I want to write it up here to remind me. Okay, and then I'm going to add it to how many I have here. So if this column is 10, this column is also 10. So now I have 10, and I have 2 complete ones, right? I have 2 complete columns. So instead of 10 up here, I'm going to do 2. And 10 times 2 equals, here's my chart, 20. Okay, 10 times 2 is 20. And then how many do I have? 1, 2, 3, 4, 5. Okay, so now I'm going to add that. I know this has a lot of steps in it. I'm trying to break it down for you. Okay. So I did 10 times 2 is 20, and then here's my 5. So 0 plus 5 is 5. And then 2, bring down the 2, I have 25. Okay, so I'm taking that number and I'm adding it to this 100. Okay. 0 plus 5 is 5. 0 plus 2 is 2. Bring down the 1. My total number of shaded pieces is 125. Now I need to write that as an improper fraction. This is an improper fraction and a mixed number. Okay. So I have one complete shaded one. Make my one nice and big. And how many was in this one? We said it was 25. Okay, so make sure my one is big, a large one, and that my 25 looks separate with a fraction line only under the 25. Okay, and then what number goes on the bottom? 100, because it's out of 100 total pieces, stays the same. So notice how there's a big one here, and then there's a 100, and I have 25 over the 100. Okay? If you know that you can reduce this, you can reduce it to 1 1/4, right? That would be simplified because 25 goes into 100 4 times, and it'd be 1/4 of it would be filled. Again, we're not stressing about that right now, so let's write this as a sum. 125 over 100 plus 120, oops, is it 5? I feel like it's starting to stick here. Over 100. Okay. And if we needed help with these steps, totally understand, but let's pause it and have you write it as a difference. Let's see if we match. I'm putting 125 over 100 minus 1 and 25 100ths. All right, that one might have been a bit tricky, but let's see if you can do this next one. That's smaller numbers, okay. So remember to put this on pause and fill it out. Welcome back. I have how many total here? 1, 2, 3. All right, so my denominator will be out of this 3. I know there are 6 parts. We don't put 6 on the bottom. It's the total number for one of those, right? The total pieces for one. So my denominator is 3. We count, I got 1, 2, 3. And if you want to do a shortcut, we can times it again. So if that was 3, how many are complete? 1, 2, 3, 4, 5. So I can take 3 and times it by 5. Okay. And 3 times 5 is 15. If you're not comfortable doing that, you can absolutely count each and every one and you would get 15 at the end. Okay. And how many is left over in here? 1. I see 1 shaded. So now I'm going to add 1 to that 15. Gives me 5 plus 1 is 6. Bring down the 1. So my total number is 16 over 3. Okay. Now I need to write that as a mixed number. We said there was 5, correct? 1, 2, 3, 4, 5 completed diagrams that have 3 in each one. So I'm going to write 5 for my big number because I have 5 whole ones. And I still have 1 left over. So 5 and 1/3. Okay. Now let's write this as a sum. We're going to write 16 over 3 plus 5 and 1/3. Now you write it as a difference. 16 over 3, and we have 5 and 1/3. Oops, did I not write this? What am I doing, a plus or a minus? Minus. All right, that is the end of page 5. I'll see you again in page 6.